So I give you guys a couple of problems to work on while I was locating my phone. Exciting stuff, I know. So you guys, why don't you guys tell me what equation you got for the first one? What'd you get? Y equals to what? Can you tell me? No? You don't understand it? Still trying to learn. All right. I thought you said you already did all the homework for Chapter 2. I am. How did you get through the homework for Chapter 2? Oh, goodness gracious. Equation. Goodness, you guys are just like my son. Like, I didn't know what that means. I couldn't do it. I said, Daniel, if you don't understand what something is on a test, you don't just not do the problem. Like, ask yourself the question, what could the teacher possibly have been interested in? Do that thing. Show the teacher you know something. Like, don't, like, you're just trying to trick them into thinking you know things, right? So, like, I know. It's just, this is my equation. It's my shorthand for equation. Here, this is equation. You guys are making fun of my shorthands. I'll make fun of your shorthands. Let's see here. And then this is the other one I tend to use. This is solution. So there you go. So now that I told you it's the equation, you can do the problem, huh? I guess we'll do it together. The slope, m, is supposed to be change in y over change in x, right? So we do the rise over the run, right? So we do 6 minus 2 over 10 minus what? 10 minus 1, so we got what? 4 over 9. And then we can use point slope. Point slope says y is equal to, 2 plus 4/9 times x minus 1. And then, of course, we can multiply that out. What do we get? We get 2 plus 4/9 x minus 4/9. What is 2 minus 4/9? How many ninths is 2? Well, it's 18 ninths. No, minus, because we got to do minus the, so it was m equal to 4/9 and 1 comma 2 for the point. Yeah. So again, if you forgot the point slope formula, if we got x1, y1, then point slope says we do y equals equals y1 plus m times x minus x1, right? That's the point slope formula. So I'm just putting in y1 is 2 and x1 is 1, so I get 4/9 x minus 1. Of course, what's 2 is what? Is 18 ninths, right? So 18 minus 4 is 14. So what we got is 14 ninths. Yeah, 14 over plus 4/9 x. There you go. So that's that. Now the other one, this is my example 2 here. This is from Chapter 3. So as I was just telling you guys, our test, which is upcoming, right, is going to be on Chapters 2 and 3. I was wrong. I think I might have said it was just on Chapter 2. I looked back at the syllabus. I'm like, oh, oops, my bad. So Chapter 2 and Chapter 3, they're very much the same theme. They're both about lines, right? Chapter 2 is about how to find the equation of a single line. Chapter 3 is about how to find where two lines intersect or don't, basically. But You don't have to look at it geometrically. We can also just look at it as an algebra problem. We got two equations and two unknowns. How do we solve it? So could you guys do this one? What is the technique for solving these? What you can do, you can use the method of substitution, right? So if we use the method of substitution, we solve one for y. So let's see, the first equation gives me y is equal to 10 minus x from top equation, right? Look, I'm using that again. You can't stop me. We'll do that next. I'm going to show you both ways. You're right. You're absolutely right. We can do that. We can add equations. And I think that's the method of, oh goodness, the elimination. Yeah, I believe that's what they call it, elimination versus substitution. Honestly, I don't much care which one you call which, as long as you can do it, honestly. But this is substitution. So we solve one of the equations for y, and then plug it into the other, right? So we get x minus 10 minus x equals to 2, right? So I'm plugging the top equation into the bottom equation, and that gives us what? That gives us 2x is equal to 12. So x is equal to 12 over 2, which is 6, right? And what's y equal to? Well, y is 10 minus x, which is 10 minus 6 here, so y is equal to 4, right? So solution is 6, 4. That's the answer here. Now let's do it your way. Let's do it your way. Your way is a better way. I almost always prefer elimination to substitution when the coefficients are nice and pretty like they are. Let me show you what I mean. Anytime we got two equations and two unknowns such that when we add the equations, one of the variables cancels out, well, then adding equations or the elimination method is just much easier than substitution. So 10 minus 6. So we had 10 minus, we had this right here, 10 minus x. So I can do 10 minus x, but x was equal to 6, right? So that's why I got 4. Sorry, it's my bad. So I should write down more steps, right? So example 2, remix. So we do x plus y equals to 10, x minus y. I'm just writing the problem down again. So what we can do is we can just add equations. And when we add equations, that means we add both sides. So on this side, you get 2x, y plus minus y is 0. On the other side, we get 12. So it gets us to the same place, 2x equal to 12, but it gets us there a lot faster, doesn't it? So this tells us that x is equal to 6. Now how do I figure out y? You just go back. Yeah, go use either one of these equations you want, right? So like 6 plus y is equal to 10. So that tells me that y is 10 minus 6, which is equal to 4. Yeah, I like that way better too. I always lead with the method I don't like, so I can throw it under the bus. So, but there's a third way. There's a third way. Example 2, remix part 2. I don't know, whatever you want to call it. What do you call the remix of the remix? It's got to be some kind of name. I don't know. So how about this? X plus y equals to 10. And x minus y equals to 2. What are these? These are the equation of lines. So this is y is equal to 10 minus x. And this is y is equal to x minus 2. So if I had some nice graph paper, I could graph these things. 10 minus x is like here. So minus x, I don't know, something like this. And x minus 2, it's down here, something like that. And like this. And if I did the graph paper real nice and pretty, I would find out that this point of intersection right here is precisely 6, 4. That's where both, y equals 10 minus x and y equals to x minus 2 are both true. They're true at the point of intersection, like that. Now, I don't recommend that you solve two equations and two unknowns graphically, because this is by far the worst method, right? I mean, if I had to pick 1, 2, or 3, 2 remix or remix part 2, remix part 2 is, we got a graph paper, we got to draw a careful graph. It's just troublesome, right? But the more important thing is to think about this. Every time you solve a system of two equations and two unknowns, you're finding where two lines intersect. That's the geometric meaning of what we're doing. It's where both equations are true, point of intersection. So, shall we do some more examples? Here, I'll let you take a picture. Or you can look at the video. It's all good. Whatever your preference is. And that reminds me, I need to take attendance. Let's see here. Oh, see, this is, I went to get the see what happened earlier was I went to get my phone because that's where I find the date from, at which point I realized I don't know what date it is. Actually, more specifically, I didn't know where my phone was, So here we go. So Stuart, Tia. Let's see here. Oops. Adriana? Dang it. I've already marked you. Oh. Curses. Well, I marked the wrong person. My bad. There you go. Bonus attendance for them. Anyway, I don't take off points for missing class, right? So it's kind of silly, but I just try to keep a record of when you came, just for the sake of. They always ask this question, like, if you fail the class, not that you're going to fail the class, but if you did, then they're always asking the question, what was their last date of attendance? And then, so like, I need to know last date of attendance, But that's irrelevant to you guys because you're all going to pass, right? Right. Okay, good. Let's do some more. And let's do the elimination method. So, what? There are 5 people. See, you raised the attendance by 20% just by coming today. I mean, think about that. That's, it's good. Example 3. So what if we have 2x minus y equals to 8 and x minus y equals to 3. We want to solve this system of equations. What should we do here? Any suggestions? So just to reiterate, we're moving on to Chapter 3. I think I've pretty much covered all the problems in Chapter 2. So if you have an additional question about Chapter 2 homework, feel free to bring it. Otherwise I'm going to go on. So today we'll be covering how to solve two equations, two unknowns, and then probably Friday I'll cover some of the word problems in Chapter 3. All right, that's my plan. Wednesday we're not meeting. Okay, so how about this? Do you guys gonna have a suggestion for me? What should I do here? Well, adding won't help, right? If I add the equations, minus y plus minus y just gives me minus 2y, right? What if I subtract the equations, though? See, I can also do that. I can subtract equations, which means I subtract the left-hand side from the left-hand side, and I subtract the right-hand side from the right-hand side. So when I subtract, I get what? I get 2x minus x, which is x. Minus y minus a minus y, those cancel out, give me 0. 8 minus 3 is 5. Now solve this equation for x. Oh, wait a minute, it's already solved. So there you go. It's almost too, this one's almost too easy, isn't it? Yeah. What's y, though? Y is 2. So you did x minus y equals 5 minus y equals 3, right? So that gave you what? 5 minus 3 equals to y. So therefore, y equals to 2. All right, so we got x equals to 5, y equals 2. So the solution, so we write the solution is the pair 5, comma 2. That's the solution. It's this ordered pair. Again, geometrically, that's the place where these two lines intersect, right? Shall we work another? Let's work another. I'll make this one ugly. 3x plus 2y equals to 10. And 5x minus y equals to 3. So, see what I do when I see something like this, I'm like, wow, man, I can't just add or subtract, right? But what could we do to make it so we could just add equations? So one of the things you can do to an equation without changing the solution set is to multiply it by a non-zero number. So this equation is the same as the multiply by 2 of it. Like I can multiply by 2. So 2 times 5x minus y is equal to 2 times 3, right? That would be equivalent, the same equation. And so that gives me 10x minus 2y equals to 6 by the distributive property. So there you go. That equation is the same as my second equation, right? So now what I'll do is I'll just write the first equation again down here. 3x plus 2y equals to 10. And now what am I going to do? I'm going to add equations, right? Because now I made the coefficients match up. You see that? So what happens? I add. What do I get? I get 13x equal to 10 plus 6, 16, yeah. So what's x equal to? 16/13. Ugly, but true. Right? What's y equal to? Which equation is the laziest one to use to find y? Yeah, go back up to this one, right? So we get 5x minus y is 5 times 16 over 13 minus y is supposed to be equal to 3. So y is equal to 5 times 16 over 13 minus 3, I believe. How many 13ths is 3? Well, it's 39/13, yeah? So we get 5 times 16, which is 80, minus 39 over 13, I think. Use your calculator if you don't trust me. I don't trust me. What do you guys get for y? I'm getting 41 over 13, but, you know, I've made mistakes before. Okay, so our solution then is 16/13, comma, 41/13. Now, I think most of the problems that you'll work in the textbook will work out nicer than this, right? I just made this up, right? That's why it's ugly, you know? I mean, we're just lucky that the one I made up earlier came out nice. It doesn't have to. Generally, the answers are fractions, you know? Is good? Well, I'll give you guys a minute to process that. As always, you guys can interrupt me anytime. If a step I make doesn't make sense or something, just get my attention, stop me. I don't mind. It's your class. I already know this stuff, you know. So it's up to you. You got to learn it, right? I cannot learn it for you. You know that? All right, so let's see here. Here's another ugly one. If we had x minus 3y equals to 7, and 3x plus 10y equals to 2. I want to solve that. So let's solve again. Solve this system. Now, we could do substitution, right? So let's do substitution this time, just for a change of pace here. Substitution. So solve, and I find it useful to label equations. This is equation 1. This is equation 2. So solve 1 for x equals to 7 plus 3y. Do we all agree? X is equal to 7 plus 3y from equation 1. Does that make sense? See what I did? I just isolated the x by adding 3y to both sides. You're like, well, that doesn't solve the problem. You're right. This is just the first step. Now, we're going to take that. I'm going to call this star. So substitute star into 2. And that gives us 3 times 7 plus 3y plus 10y is equal to 2. That's a good thing, because now we've got one equation and one unknown. And we can solve those all day long, right? That's like day 1 in here. We usually have the letter x, but we have the letter y. It's no big deal. This gives us what? 21 plus 9y plus 10y is equal to 2, which gives me 19y is equal to 2 minus 21, which is minus 19. Whoa. Whoa. I made this problem up, guys. But one of the answers is minus 1. That's cool. You got to understand, that's very unlikely in terms of like just the probability of me getting a whole number answer. That's cool. 19 over minus 19 is minus 1, right? What's x? Circle back to star, right? X is equal to 7 plus 3 times y, which is what? Well, minus 1, right? So x is apparently 4. Solution. 4, comma, minus 1. Now, Tia, you don't like this because I didn't. You what? But you don't like because I did the substitution method, right? Oh, you did this one too? Yeah, the other way to do this would have been the multiply. I would have multiplied the first equation by 3 and then subtracted equation. That's the other way I might have done this. Because if I like multiply the first equation by 3, then I could subtract, and we could do it that way. Want me to show you? Okay. Is that a real or is that just a polite Uh-oh. You want it? Okay. All right. So example 5 remix. So I take 3 times 1. That gives me 3x minus 9y equals to 21. And I just keep equation 2 like it was. I take these, I subtract them. So my whole strategy here is multiply the one equation by a number to make either the terms with x or the terms with y match up. Because once they match up, I can either add or subtract them to make them cancel out. That's the trick. So here they cancel out, and I get minus 19y equals to 19. We're back where we started. Y equals to minus 1. Happy day. And then x, well, I guess finally, find 3x plus 10 times minus 1 equals to 2. So 3x is equal to, what? Oh yeah, I'm an idiot. 12. I was thinking I got minus 8 or something. I was like, I wasn't adding 10 to both sides. It was messing my head up. So x equals 2, 12 over 3, also known as 4. Hooray! So same answer again, 4 comma minus 1. Any of these problems, it doesn't take long, right? Especially if your answer is not a fraction, even if your answer is a fraction, to check your work. How do we check our work? Plug them back in, right? So let's check our work. Try it out. So x minus 3y is going to be 4 minus 3 times minus 1, which is 7. 3x plus 10y is 3 times 4 plus 10 times minus 1, which is 12 minus 10, which is 2. So, good news. We got 7, and we got 2. So, oops. Hooray! Of course, the other thing, like logically speaking, is we solved the problem 2 different ways and got the same answer twice. For us to be wrong both times, it would really be somewhat miraculous, you know. We would have had to make so many mistakes in exactly the same way in both problems to get it wrong twice the same way. But anyway, check answer, yeah. Shall we work another? Let's work another. You're like, I'm bored with 2 equations and 2 unknowns. Let's do 3 instead. Let's not. You guys don't want to do 3 equations and 3? It's the same stuff. It's the same technique. Like, it's not really any different. Oh, but three equations. So like, 3 equations, 3 unknowns. You got to think about it like this. This is x, this is y, this is z, in like 3 dimensions. So in 3 dimensions, if you have an equation like x plus y plus z equal to 0, that's the plane through the origin. It's like a plane through the origin. And if you had 2 of these equations, like another one would be this, that'd be another plane through the origin, looks like this. You know, and they would intersect in like some kind of line. Fine. You caught me. It's not intermediate algebra. It's true. It's all true. Everything you say. See, if you went to an auto dealership and you're like, I'm going to buy, Model L or whatever, and then they were like, For the same price, we're going to give you the XL model. You wouldn't fight them. You'd be like, thank you for the more expensive and feature, a car with more features. Education is the only thing where you try to give somebody something with more features for the same money. They're like, no, stop, don't do it. I just want the base model. Stop what you're doing. Example 6. Sorry, I'll behave. So what if we got 7x minus y equal to 10, and then 3x equal to 2y plus, 4. Here's 2 equations, 2 unknowns. Let's solve this. You're like, hey, you made it ugly. Like, it's not. So what do we do here? What's the first thing you do? So what I would do is I would say, well, this is the same as 7x minus y equals to 10, and 3x plus 2y equals to, minus 2y rather, right? Equals to 4. Now I'm back to kind of like the standard setup. And I could try to do elimination. So if I multiply the second equation by 2, multiply by 2, it gives me 14x minus 2y equals to 20, right? And then I can subtract equations. Yeah. It's all good. Yeah, I got to distribute the 2 through, right? Like, so this is equation 1. This is equation 2. I would call this 2 times equation 1. That's what it is. We multiplied equation 1 by 2 there. Anyway, at this point, I've done.
How were you able to put the 2 into the first place?
See so like we started with this, right? Before this, we had this, right, up here. So I look at it and I go, I want to add or subtract equations for the method of elimination, but to do that, I either got to make this and that match up to cancel out, or this and that to match up, right? Now, making 3 and 7 match, that's a pain. I'd have to multiply this one by 3, and I'd multiply that one by 7. I don't want to do that. It's a pain. I've got a y here, I've got a 2y here. All I got to do is multiply the first one by 2 to make it match up with the second. That's my internal logic. That's why I multiplied by 2. You can always multiply. It's like the least common multiple problem. It's that same can of worms. Anyway, so once we have that, right, we can subtract, right? And we get 3 minus 14, which is, minus 11, right? These guys cancel. 4 minus 20, minus 16, right? Looks like x is going to be equal to minus 16 over minus 11, also known as plain old 16 over 11, right? The minuses cancel. What's y equal to? So which one do we want? I think I'm going to use equation 1, because that's the easiest one. Y is like, so from 1, we have 7 times 16 over 11 minus y equals to 10, right? So y equals to? 7 times 16 over 11 minus 10, I think. So I just... Now, that, 7 times 16, that's 70 plus 42, that's 112 over 11, and this was minus 110 over 11. You said it was what? I agree. Yeah, you guys use a calculator. Don't be a dummy like me. Let's see here, 16 over 11. I mean, I'm being foolish because, like, if I'm tired, I'm going to make a mistake in this stuff, right? And so. Oh, I know what we haven't done yet. I know. Example 8, example 7. Aha, 1/2 x plus 1/3 y equal to 1/12, and x minus y equal to 0. So how would you guys like to solve this one? See, this one, I think that substitution's the way to go here. Substitution's very natural here, because the second equation, I just get what? Y equals x, right? So if I call this equation 1, call this equation 2, from 2, right? And then we can substitute that into equation 1. What do we get? 1/2 x, right? Plus 1/3 x equals to 1/12. How are you going to solve that? I should do more examples with fractions in here for you guys. I'm sorry I don't. I may make that a mental note to myself. More fraction examples, because we need to see more fractions, right? So you got choices here. You can add 1/2 to 1/3. What do you get? What's 1/2 plus 1/3, right? Yeah. So this is 5/6, right? So another way to look at that, of course, is 5x over 6, right? Is equal to 1/12. So we can cross multiply, and we get 5x times 12 is equal to 6, right? Which gives me 60x. Now, you don't have to do it my way. If you got another way to do it, by all means, do it another way, all right? But I get 6 over 60 for x. Which is, of course, 1/10. Which, by the way, is equal to y, right? What's the easier way to solve this problem? If you don't want to work with fractions like that, what I always do is I just pick the biggest, baddest fraction and multiply by it to get rid of it. Here, the biggest, baddest one is 12. Multiply by 12. What do you get? 12 over 2 is 6. 12 over 3 is 4. So it pays to eliminate fractions before making steps, right? I mean, we can add fractions and go through the steps if we're careful, but it also sometimes pays off to just multiply the equation by a number to make the fraction go away. So generally speaking, multiply by the least common multiple of the denominators in the problem. That should clear out the fractions. Anyway, so I still need to talk to you guys about the 3 different cases. What are the 3 different cases? You could have lines. So the 3 cases are, one line's like this, one line's like this, one line's like this. The other line is like that. The other line is like that. The other line is the same line. These are the 3 cases geometrically. Every example I've done today has been like this. We got one answer, a unique solution. However, if you have parallel lines, there are no solutions. And if you have the same line in disguise, you have infinitely many solutions. So we'll do some examples like this next time, but we're out of time for today, so I'll stop. Again, no class Wednesday for us. Everybody else has class, just not us. So take that time to work on your homework. Thanks, guys.